Today we're going to break down one of the most foundational tools in all modern product development and manufacturing systems: failure mode and effects analysis. FMEA is the structured and systematic process of reviewing as many components, assemblies, and subsystems as possible to identify potential failure modes in a system and their causes and effects. But instead of giving you theory today, I'm going to take you into an actual FMEA meeting, the kind of meeting you'll experience as design or quality engineer. Our product is an electric cooling fan module that consists of a plastic fan, DC motor, an ECU housing, and a connector and wiring interface. An example simple enough to follow, but realistic enough to match automotive expectations. And our task is to perform a design FMEA on the fan module's cooling performance and reliability. Setting inside the meeting: Lena, the design engineer; Michael, the motor specialist; Sarah, which is you, the FMEA moderator or the quality engineer; Ray, testing engineer; and Emma, the project manager. Sarah opened the meeting saying, "All right team, today we're assessing design risks for the electric cooling fan module." So the first step in FMEA is to define the function. Here you turn to Lena, the design owner. The cooling fan's primary function is to pull air through the radiator and maintain engine temperature in the safe range, between 85 and 105 degrees Celsius. Then come the second step, identifying the failure modes. You ask the group, if the fan fails to perform, how exactly could it fail? Then the team starts listing all typical failure modes. Failures like the fan doesn't spin properly, insufficient airflow, and fan blade cracks. Now you collect these failure modes and list them in the FMEA spreadsheet. Then we move to step 3, which is identifying the effect of each failure. Here Ray, our testing engineer, jumps in. If the fan doesn't spin, this may lead to engine overheating and potential engine damage. Insufficient airflow will lead to reduced cooling and AC system performance drop. And in the case of fan crack, flying debris increases potential safety hazard. Now you add these effects to your sheet and add a column and call it S. In this column we try to track the severity of each effect. Now the severity is rated from 1 to 5, or in some case using Latin letters from I to V, where 1 is lowest severity or not relevant for reliability or safety, and 5 is highest severity or catastrophic. So for engine overheating, we would give it 4, for reduced cooling 3, and for the flying debris a solid 5, as it may lead to a safety hazard. After that, we move to the next step, identify causes and assign probability. Here in the causes column, we try to list the reason causing each failure. The reason for the fan to stop spinning may be because of an electrical short inside the ECU. For the insufficient airflow, it could be that the motor brush wear out. And for fan blade cracks, we have possible causes like poor weld at blade hub or material degradation at high temperatures. After identifying all possible causes, we assign probability score, from 1 to 5, where 1 is extremely unlikely, and 5 is frequent. Michael says motor brush wear is common in early life testing, so we should give it 5. Lena says electrical shorts are very rare. It will take 1. As for the poor welding is occasional, so it takes 3, and the material degradation is also very rare, so also 1. Now we move to the next step, the detection. In this step we have a look at the method by which a failure is detected, and if the failure is detectable or not. The detection is rated from 1 to 6, where 1 is certain and 6 is undetectable. So we add the detection score in the FMEA sheet as follows. Motor brush wear is low detection, so we should give it 5. Electrical shorts are certain, so 1. The poor welding is moderate, so 4. And the material degradation is almost certain, so it takes 2. Now comes the most important step, which is calculating the risk priority number, or the RPN. So RPN is calculated by multiplying all the probability, severity, and the detection all together for each failure. And we do this to prioritize which risks we should have correction actions for, and which risk that we can live with or ignore for now. After that, we add a column for risk mitigation, and we define corrective actions for each failure, like adding temperature fuse in ECU or increasing blade hub thickness for better welding. And at the end, we add columns for assign ownership and due dates. And that is exactly how a real design FMEA plays out. Now, some companies use different rating scale, others use advanced software for calculating the risk, but the methodology stays the same. A structured conversation that forces the product teams to ask themselves, how could this design fail in the real world? Then find risks early, prioritize them, and eliminate them before they reach the customer. Now, before we finish, there are two major types of FMEA you must know: Design FMEA and Process FMEA. The DFMEA analyzes product design risks, geometry, materials, interfaces, loads, tolerances, electronics, and so on. The primary aim here is to prevent design-related failures before any prototypes or tooling are made. It is normally used in APQP Phase 2, Product Design and Development, or in VDA MLA levels, ML2 and ML3. Basically, before drawing release, before A samples. On the other hand, the PFMEA analyses manufacturing and assembly process risks: machining, welding, molding, assembly, testing, and handling. Here it aims to prevent process-related defects and ensure stable, capable manufacturing. It is normally used on the APQP Phase 3, Process Design and Development, or in VDA MLA levels ML4 and ML5. Basically, before process approval, or before B samples.
If you found this video helpful, don't forget to give it a like and drop a comment below. We'd love to hear your thoughts or questions. And if you're into leveling up your skills with expert-led content, hit that subscribe button and turn on notifications. For full courses, downloadable assignments, and certifications, head over to excetify.com. Start learning smarter today.